Topic 2.2, defining the derivative of a function and using derivative notation. So recall from 2.1, this is the definition of a tangent line using limit notation. We are going to consider this. However, we're going to say that x is equal to c plus h. So our x value is going to be c plus h. So if you refer back to our last set of notes, if we go over h, this point right here is now c plus h. If we go over h, this point right here is now c plus h. So our delta x is now c plus h. Our delta x is getting closer to 0. We can find the limit of the secant line, which will produce the tangent line slope. So what we're going to do here is we're going to go ahead and make that substitution for x. So the limit as c plus h approaches c of f of c plus h minus f of c all over our x value, c plus h minus c. And what you end up getting here is the limit as h approaches 0. And I told you that's our delta x, so that makes sense. Our delta x is approaching 0. Our h is approaching 0. And then on the top, we have f of c plus h minus f of c all over h, or delta x. So this is an alternate form of the derivative. So you need to recognize that as h approaches 0, you're dividing by h here. This as well means first derivative. Down here, first derivative. Or as I was saying, delta x equals 0. So delta x not equals 0, I'm sorry, approaches 0. So instead of using an h, they may use a delta x. So there are 3 different forms we've covered so far. So let's take a look at this example here. It says we're going to differentiate this. Okay, if we differentiate this, that means find the derivative, which means find the slope of the tangent line at any x value, because they don't give us one. So what we're going to do is we're going to use the alternate form. We're going to do the limit as h approaches 0, because we don't know what x value they want. We can find the derivative or the slope of the tangent line at any x value. So this right here is f of x plus h minus f of x all over h. And we need to find the limit. Well, these square roots, you should think of your algebra multiplying by the conjugate. So we're going to go ahead and do that. The square root of x plus h plus the square root of x all over the square root of x plus h plus the square root of x. And when we multiply, we will get the limit as h approaches 0. This is a difference of squares pattern. So we're going to FOIL this in essence, and it's going to be first times the first, and you're going to get x plus h. The outsides and the insides will cancel, and then you're going to get the last two. When you multiply the last two, you get a negative x. Square root of x times the square root of x all over h times the quantity, square root of x plus h plus the square root of x. So I'm just not going to distribute that right now, and you'll see why. So continuing, again, do not drop off the limit. This is called the limit process for finding the first derivative. So on the top we have an h, and we have h over the square root of x plus h minus the square root of x. x. And notice the h's cancel, and you're left with the limit as h approaches 0 of 1 over the square root of x plus h minus the square root of x. Now we can evaluate the limit by plugging 0 in for h. We plug 0 in for h, we end up getting 1 over the square root of x plus 0 minus, oops, I'm sorry, that's supposed to be a plus, plus the square root of x. So in the end, you get 1 over 2 square roots of x. You have just found the derivative, the slope of the tangent line at any x value on the square root function. So if I wanted to find it at x equals 1, I would plug in 1, and my tangent line slope would be 1/2. This is the limit process. The good news is you will never have to use the limit process to find the derivative. We are going to give you the shortcuts that you get to memorize to come up with this answer here. However, you do have to recognize all three forms of the limit for the first derivative. So let's take a look at that next. Okay, so for this particular problem, this is as h approaches 0. This is f of x plus h. So if you look at this, if this is f of x plus h, then that means our x value must be 9. And our function must be the square root of x. So if it's the limit as h approaches 0 of f of x plus h minus f of x all over h, isn't the square root of 9, isn't this right here, our f of x, the square root of 9, isn't that equal to 3? And isn't f of x plus h the square root of 9 plus h? So all you have to do is identify what the x value is and what the function is. And that's all you have to do. Okay? Take a look at this one. This is delta x instead of h. So this right here is our f of x plus h. Well, there is your x plus h, or your x plus delta x. Delta x and h are the same thing. So this right here tells us that our x must be equal to a -3. And this whole function here, our f of x, must have been 2 plus x cubed. Okay, then the third form, coming from lesson 2.1, the limit as x approaches c of f of x minus f of c all over x minus c. That's this form right here. So this right here is our f of x. So f of x equals the cosine of x. And our c value, or our x value that we are using, is pi over 3. So this right here, 1/2, is the cosine of pi over 3. So in the assignment, they are going to, the directions will say, find the derivative. And you are not going to find the derivative, you are just going to identify what the function is and what x value you would be finding the derivative of. But that's it. That's all you have to do for the assignment, is tell me these two things.